Hey everyone! My room is messy, but I'm a college student. In this video, we're going to be discussing the top 10 mistakes that students make on the Math IA. If you don't know what the Math IA is, it's basically the assignment that you have to do if you are going to be taking the math programs in the IB Baccalaureate. It's basically like a research paper where you have to use math to learn something about the world and write a 12-page-ish paper about it. I graduated the IB in November 2019 and I got a 7 in maths and I got a 20 out of 20 in my assignment. And since then, I've been working with students as a tutor, where a lot of the work that I do is working with students to try and help them improve their math IA to bring it up to a 7. Over the past year now, I've read dozens and dozens of math IAs, and the same mistakes keep popping up time and time again. So in this video, we're going to be discussing those. And before I talk about that, let's just talk about some stuff in general. So when I'm working with students and I give them basically advice on every single bit of detail of their math IA and rip it to shreds, sometimes students feel bad about that because they didn't realize how many mistakes that they made, and they're anxious about oh my god, how am I gonna fix all of this? And yeah, I completely understand that, but yeah, for anyone who's doing the math IA process at the moment, you should know that that is very normal. Basically, for every first draft that I've handed in was ripped to shreds by my teachers. There was corrections and little question marks and red ink all over the page. So yeah, when you're giving your first draft, whether you're working with a tutor or working with a teacher, unless you're a genius and you've done this before, if this is your first time doing a math IA, then you should expect back lots and lots of corrections. Within my private tutoring business at the moment, I offer services for IA checking and IB tutoring in general, and if you end up signing up to one of those services, yeah, expect there to be lots and lots of comments and lots of suggestions that you should change. Rarely do I get an IA where there's no feedback that I can give. There's always a lot of feedback, just on very specific details sometimes, that I can give. Never got an IA which I've been this is perfect. Never happens. This is partially because mathematics is just a very you gotta be really specific and really careful with the words that you choose, because if you misrepresent a concept or if you misuse of a technical term in a very specific way, then that can seriously put off the examiner and lower your mark. In the IAs, the points come from the details. If there are lots of little baby issues here and there, which could be really small, just one sentence long, that can be the difference of a whole point. Communication is worth 4 marks. In order for you to get full marks on communication, the exploration must be coherent, well organized, concise, and complete. For any of the kids who I've worked with, who have shown me their math IAs, I probably would have never given a 4 for any of them. And that's precisely because the overall structure of the IA is fine, but it's the details which need refinement. So yeah, if this is your last day to work on the math IA or something, really go through the details, read it out loud, put it through Grammarly, do everything that you can to try and comb through all of the baby mistakes that you can find. And without further ado, I've rambled on for too long now, let's start talking about the common mistakes that kids make and how you can potentially correct for them. Okay, so the first mistake that I see is over-indexing on personal engagement. Personal engagement is worth 4 marks in this math IA, but I think there's lots of misconceptions about how you should actually use personal engagement and how you get personal engagement marks. What I see a lot of kids do is that they think that they're going to get personal engagement marks by telling this cheesy background story about their life and how it very loosely relates to their research question. Whilst it is good to do something that you're interested in and explain why you're interested in it, this is only one small part of personal engagement. Given that it's 4 marks, there's a lot more to it than that. Personal engagement is about showing how you actually engaged in the assignment proactively. This can be through collecting your own data, doing something that is just in general reasonably interesting, showing reflection and that you did a preliminary experiment and then improved in the next round, avoiding doing anything that's really basic, using maths in a reasonably cool and interesting way that shows that you're being creative, and just in general really showing that you took initiative to try and put effort into your assignment. I personally think that showing a diagram with lots of pictures, which you made by yourself, can also help show personal engagement, because it shows that you actually took the effort to try and formulate the concept in a visual way, which is harder than just writing it out. What differentiates a 3 from a 4 is basically just the wow factor. Whether or not your findings actually discovered something interesting about the world or not, or whether it was just basic, the results didn't mean that much, or that the answer was intuitive anyways, and yeah. So yeah, you don't have to write some sort of cheesy background story about how linear regression really relates to your life. If you want to get high marks in personal engagement, it's not that difficult. You just have to proactively engage and show that you tried hard. This is the try hard marks. Kids who do things that show that they tried hard are gonna score well in personal engagement. Okay, the second most common mistake that I see is having a crap research question and not doing the aim properly. So the research question should include whatever variables that you're trying to measure and whatever mathematical analysis that you are going to use to try and discover whatever it is you're trying to discover. It should also be not too broad and not too narrow. And you're gonna have to try and figure out what the balance is between these. Usually I see ones that are too broad. For example, a really standard format for the Math IA research question could be, what is the insert number here of subject topic here? So for example, for mine, I did, what is the fractal dimension of 2 Indonesian islands? And then my whole IA was basically about calculating the fractal dimension of 2 Indonesian islands. My friend did, what is the volume of a wine glass? So she spent the whole IA calculating the volume of a wine glass. It may have been a bit more fleshed out than that, but that was basically the standard format. So in the case that you don't have a research question, you would want to have at least a very specific aim, which tells the examiner exactly what you want to do. If you have a research question, you should also have an aim. And basically what the aim is that it is a roadmap of what you are going to do in your Math IA. I've read a bunch of Math IAs, and basically everyone messes up the aim because they either add in a bunch of extra background information, or they don't actually specify exactly what they're going to do in their IA, and then I'm confused because I'm reading it, oh my god, what the hell is happening here? I don't know what's going on. It would have been a lot easier if you just specified what you were going to do exactly in the beginning and state exactly what you're going to do. So for example, if you wanted to use some sort of simulation to show something, you would do, the aim of this experiment is to code a simulation to do X. And it shouldn't be any more or less than that. If you're doing linear regression or something like that, then you would do, what is the correlation between X and Y? I see a lot of them which just have the phrase relationship between them. What is the relationship between X and Y? I mean, this may be controversial, but for me, I feel like that's a bit vague. The relationship between, what sort of relationship are you going to be trying to determine here? I don't know. Additionally, another sentence I hear a lot in not just the aims, but in other parts of the IA is this phrase, I'm going to do this to build my understanding. I hate this phrase. Look, I'm not an IB examiner, obviously you can't take my word to heart, but I kind of hate this phrase because I feel like when you're saying, oh, I'm going to do this to improve my understanding, it's because you don't actually know why you're doing it, and so you're just going to say you're going to do it to improve your understanding without actually having a specific purpose. You just want to fill up the words. Developing your understanding will be shown throughout the A, regardless of whether it's an aim or not. You can still say that somewhere, oh, I wanted to develop my understanding, that's fine, but the understanding part is going to come along. Your actual aim and research questions should be specifically about, what are you trying to learn about the world? Because that's what this math thing is, right? We're trying to learn something about the world. Whether, I don't know, Michael Jordan scores more points than LeBron, or whether you're, trying to figure out what the stock market is going to be like next year or something. You're trying to learn something about the world. Your understanding will come when you are trying to learn something about the world. Personally, I would limit my use of that phrase. So yeah, to summarize what we just talked about, your aim should specifically be a roadmap that describes whatever you're going to do. Your research questions should be very specific and describe the variables that you're going to be discussing. If you're going to be doing multiple things, you can explain that in your aim. First, I want to do this, then I'm going to do this to find this, and then I'm going to do this, which will finally get me to this. That should basically be what your aim is like. Don't give any background information in the aim. That's really weird. Okay, a fourth mistake that I see a lot is forgetting to explain/interpret things. Now, there's going to be a balance between explaining things and just assuming that the examiner has a basic understanding of whatever it is you're talking about. For the most part, I see a lot more forgetting to explain and interpret stuff. I do see a lot of explaining too much on the easy maths that is very obvious. I would try and write it to the level that I should be able to give it to my friend and they should be able to understand what I'm doing. So I don't have to explain in detail that I'm going to multiply this thing by 2 and then I'm going to divide it. You don't need to show the simple steps, but anything that you think that your friend who's on basically the same level of maths as you would need a little bit of explanation about what's going on, you should try and explain that. Sometimes before each section, I immediately see kids immediately starting off by listing off all of their equations and showing their derivations, and I'm like, whoa, what is happening? I have no idea what's happening over here. It's because they didn't explain what they were doing before they started doing the calculations. Just even like a sentence or two of explaining what you are doing as you are doing your steps can really help the examiner figure out what the hell you are doing. Additionally, you need to justify everything. So, oh, you picked those 2 islands to analyze? Why those 2 islands? If you are doing a statistics IA and you're going to be analyzing data, you seriously need to spend like a whole paragraph basically analyzing your data set. If you did history, you should basically OPVL that data set. For anyone who didn't do history, basically you need to be discussing like, you should probably try and discuss the origin, the values, the limitations, strengths, weaknesses of whatever data that you are going to be collecting, because you are going to be basically making inferences about a whole population based off a sample, and you want to evaluate whether that sample is valid or not. Don't explain obvious things. What I would recommend if you really care about this is that first just start off by explaining as much as you can, then ask a friend to go through it and see if they understand what the hell you're talking about, and ask them to underline anything that's really obvious. Okay, my 5th tip is that, oh my god, please make the equations look nice. There is a feature on Google Docs and Google Word where you can insert equations and you can basically use the different symbols and make the equations look really legit. Just Google how to use equations in Google Docs, how to use equations in Word. The Google Docs one is a bit of a pain in the ass, but if you play with it enough, then you'll figure it out. If you're going to use numbers and if you're going to use symbols, never use Arial or Times New Roman font. Font of the equations and the variables should be a different font to your written text. Even when you're writing within the paragraph, please use the equations feature. It just makes everything look prettier. Okay, the next thing that we're going to be talking about is you guys have some ugly ass graphs, which y'all need to correct because, oh my god, I'm always commenting on okay, what's the y-axis? What's the x-axis? What are the units? What are the uncertainties? Why this title doesn't make any sense? So essentially some common mistakes are not labeling the x-axis properly, not labeling the y-axis properly, making the title just this versus this, which is kind of lame and it's kind of obvious. When you're doing your graph, you should have a detailed caption which explains what the graph is and explains any relevant features, just in a little paragraph above the title. You should have the equation and the r-squared value on the graph, and then in your data analysis section, you should be analyzing the equations and the r-squared value. Additionally, the formatting of your graph should be consistent. Sometimes a kid will do their graph in Google Sheets, and then they'll show a graph that they made in Excel, and then a graph that they made in Desmos, and all of the graphs look different, and it's really annoying. I think for communication purposes, it's worth making sure that the style of all of your graphs is consistent. So yeah, you shouldn't make one graph blue and then the other one red. It just looks weird, so don't do that. Even keep the fonts the same, the grid lines the same, unless there's a reason why you shouldn't do that, Another thing is that often kids just miss out on the uncertainties of their graphs. This isn't as important as it would be in a science IA, but if you're going to be measuring anything, then you need to include uncertainties and you have to justify those uncertainties, how you calculated them. So if you're doing any sort of calculation and then you're putting that on the graph, you should be explaining that as well. Don't just assume that oh, we can see the graph and then we can imagine the maths that you did. No. Every bit of maths that you do, any bit of maths that you do in your data processing section, you should explain it. I would just do this with example calculations. So if I was doing some sort of standard deviation equation and I was actually calculating it myself, I would show that. And yeah, just so you know, if it's not in your IA, the examiner assumes it's not there. They can only see what's on your IA. If you did something and then you didn't put it in there, then you're losing because they have no idea that you did that. Additionally, a problem I see a lot is, so the graph looks like this, and then but all of the data is over here because you want to keep the origin point over here. Don't do this. You can shift the graph so that it fits all of the data points. So imagine that this is the 0 axis, but then your data is only over here. You don't have to keep all of this extra random white space. It looks really ugly. Change the x-axis and y-axis scale so that it fits the data, so that there's no random white spaces in your graphs. Okay, I don't really know what number we're on at the moment, but another thing is the misuse of technical terms. This is going to be hard for you to spot out, but essentially a lot of mistakes that I see are just just would be a complete misuse of a technical term, saying causation when you mean correlation, saying something like, oh, this is significant when you haven't done a hypothesis test for it. There are a lot of terms that we use in daily language which are actually mathematical terms, which can sound really weird, and if you're trying to use them in Math A, unless you're doing significance testing, which is a mathematical analytical technique in maths, you shouldn't be using the word significant to talk about your results unless you are doing some sort of statistical significance test about them. The word significant means something very specific in maths, and if you just use that like colloquially when you're trying to discuss things, then that can seem like you just don't know your stats properly or something. So yeah, I see a lot of IAs where kids are just like throwing in math terms without really understanding what they mean, perhaps to try and sound like smart to the examiner. Please don't do this. Only use a technical term if you really know what it means, because if you misuse it, that's like 100 times worse than like, seeming smart because you used a fancy word. Your Math IA shouldn't be confusing to read. It should be readable by your friends. And so give the examiner a break by just using normal language and technical terms when you need to. Okay, let's talk a little bit about some stats IA problems which I see, because those are the ones which I've been looking at the moment. One thing I see a lot of people forget is that they think that because this is in a science IA, they don't have to talk about variables. If you're doing a stats IA, you have to talk about the variables. If you're doing a correlation test, you should definitely talk about your independent variable and your dependent variable and potential confounding variables and extraneous variables and controlled variables. So yeah, that is just something that I see that's just completely forgotten about in stats IAs, which you should probably slip in there. Another problem with stats IAs is that kids confuse correlation with causation, and so they say that they're going to make predictions about something and then they're going to devise this amazing equation that's going to allow them to predict the future, when that's not really what's going on. Or they've specifically stated like, hi guys, I found the causal mechanism between these two variables, when what you're really doing is actually just finding a correlation between two variables. So yeah, if you're doing a stats IA, I'd be very careful when you use the words like prediction and cause and anything that kind of asserts that you have found like a causation between two things, because statistics is based off induction. Correlation does not equal causation. For example, this graph shows that as ice cream sales increase, so do shark attacks. Now, does this mean that ice cream sales increase shark attacks? No. What is the correlation between these two things? Now, the reason why there's a seemingly correlation between these two variables is that in the summer, more people buy ice cream and more people go to the beach. And when people are at the beach more people get eaten by sharks. Alternatively, in the winter, not many people buy ice cream and not many people go to the beach because it's freezing, and so not many people get eaten by sharks. So in this case, the confounding variable, which explains these two variables, is actually just like the natural temperature, which creates this suspicious correlation between these two variables. So yeah, just remember, correlation does not equal causation. Be careful with what you try to infer from your results. Okay, finally, this is my last thing I'm going to be talking about, is that I work with a lot of kids who are pressed for time and they try to use someone else's method and apply it in a new setting without fully understanding what it is the person did. Like they want to do some sort of stats test, and so they just copy the stats straight out. However, the claims and jumps that they made work in the first person's IA, but don't necessarily work in the second person's IA, and it would take a different approach in order for it to make sense. But because they copied it straight out, it's just really weird and doesn't make sense. It's definitely okay to work on and build off of other people's IAs to like get ideas. The IB is not expecting you to do something completely original. So yeah, I definitely would recommend looking at other people's IAs for advice. But I would also recommend you to do just a bit more research around the subject which they are doing to actually try and fully understand what it is they did and why, instead of just copying out what they did step by step, because unless you're really good at it, like, it just usually doesn't go well. I've read some other IAs where people have tried to take ideas from me. For example, I've seen a few IAs that people have sent to me where they try to do the fractal dimension thing, and they always have problems because the kids did not actually understand what the fractal dimension was and exactly how it's calculated or processed, and so they make a lot of mistakes in the calculations and in the background explanation where they're trying to explain the background information, presumably just because kind of just tried to model whatever I did without actually taking the time to try and understand the content. I'm all for kids, taking inspiration from whatever IAs that I put out there. I'm all about sharing ideas, and I'm not really worried because I know there's no way to plagiarize because Turnitin is going to catch you, but it is true true that for the most part, people who I've seen who have tried to do the fractal dimension don't actually understand it, and that causes them to make a lot of mistakes about it. So for reference, I probably spent like 2 weeks heavily researching fractals before I even started my method, because I wanted to make sure I was completely clear on what everything in the fractal universe thingy, whatever I was exploring, meant, so that I wouldn't make any silly mistakes along the way. So yeah, for example, it's not like I invented the fractal dimension method. I also too took it from someone else, but I spent a lot of time trying to actually understand what the method was before I even began to use it. So yeah, that's my recommendation for you. If you want to score high, you gotta spend time reading and actually trying to wrap your head around the concepts that you want to try and explore. Okay, yeah, and that's about wraps about for this video. Thank you guys all for watching. If you have any questions, please leave them in the comments below. You can also DM me on Instagram. I pretty much answer every single comment on there. At the moment, I'm working on building my IB tutoring business, so right now the website isn't up, but if you are interested in getting any sort of tutoring or IA services, please feel to shoot me an email. You can find more information about that in the description below. And I wish you guys the best of luck with your math IAs. Cheers!